Hello, wonderful class. I miss you all so much. I know you're going to behave yourselves today. So since I am gone, I made you a nice little video of what we're learning today. Not that Mr. Perkins could not teach it, but I figured since you all would probably miss me so much, you would much rather hear from me. So you should make sure that you have your yellow packets out, and we are going to talk about today's lesson. So we are going to be turning to 5.6, so just make sure you are in that section of your packet. So a couple of things is today we're talking about direct variations. Just a quick note is that I'm going to be referring to these as DV because I don't want to write direct variation 5,000 times. So when we're talking about direct variations are just a linear relationship. So remember, don't overthink linear. They're just referring to a line, okay? When we're talking about direct variations, like in the book, they're going to say it's like y equals kx, but what's silly is that they use y equals kx, and what we're going to use is just what we've been using this whole time, which is just y equals mx, okay? So remember, we've talked about y equals mx plus b, and k and m, same thing. Don't worry about it, it's just the book decides to do something fun and different. So direct variations are pretty much in the form of y equals mx. You'll notice it's different from y equals mx plus b because there is no b. So for a direct variation to be a direct variation, pretty much it just has no b. It just has a slope and no y-intercept, okay? So when we're looking at this, that like m or, k or whatever we're using, but again, we'll use m because it makes more sense. Whatever that letter is that they're using, that just stands for slope, okay? So in the book, if you see it as k, fine, it's the same thing as m, but whatever they're asking for, k and m, those are actually just going to be your slopes. So if we're looking at an example of a direct variation, so an example of a direct variation would be something like y equals 2x, okay? I have my y equals 2x, that's the same form as the y equals mx, which I know I need for direct variation. Something that would be not a direct variation would be if I saw like y equals 2x plus 1, okay? So that's not a direct variation because I have that for y equals mx plus b, I have that b value right there, okay? For it to be a direct variation, remember I have to have this form, I can't have any plus or minus some number, okay? So direct variation, not a direct variation. So let's just do really quick examples. So if I want to identify if something is a direct variation or not, okay? In order for me to do that, I want to get y alone, okay? Similar to y equals mx plus b, I just want to make sure I get that y alone. And if I can get the y alone, and if I can get it into y equals mx form, that would mean that it's a direct variation. So let's take a look at an example. And I'm just struggling to figure out my camera today, no big deal. Just talking to myself, the usual. So let's say I have, let's do negative 3x plus 5y equals 0, okay? So again, to figure out if it's a direct variation, I want to make sure that I try to get y alone, and if I can get it into y equals mx form, it would be a direct variation. So I guess we can fake raise our hands. So who would like to raise their hand and tell me the first thing you would do if you wanted to try to isolate y? And by the way, everyone, this is so awkward because I'm sitting in my classroom alone doing this whole thing, and I'm looking around pretending like you're all here, but you're not. So I'm going to pretend like someone's raising their hand. Who would like to tell me my first step? Oh, Trey, go ahead. Oh, Trey said it correctly, of course. So I'm going to add 3x to both sides. Thank you, Trey. And I'm left equals 3x. My y is still not alone. Would anyone else like to raise their hands and tell me my next step to get y alone? Oh, Remy, thank you. I would divide both sides by 5. So if I divide both sides by 5, I'm left with y equals 3/5 x. So, I didn't give myself enough room, but if I look at this, y equals 3/5 x, y is totally alone. Is that in y? Would anyone like to raise their hand and tell me if that's y equals mx form? Oh, who? Let's see who. Oh, Brianna, yes. It is in y equals mx form. And so my answer is just yes, it is a direct variation. And as a side note, if they ask you what's the slope or what's the constant, my slope or constant, whatever, in this case would be 3/5. Questions? Not that I can answer them. Wonderful. So let's do a second example. All right, so let's take a look. Let's do 2x plus y equals 10. Okay. Who would like to raise their hand and tell me what I do first? Oh, Israel, go ahead. Oh, yes, you are right. I'm going to subtract 2x from both sides. And what's it going to look like next? Oh, yep, thank you, Israel. So Israel did a great job of making sure I did my x, and I have y equals negative 2x plus 10. Is this in y equals mx form? No. And why is it not? Yes, everyone, of course, because I have so no, it is not a direct variation. And that would be my answer. Questions? Wonderful. Okay, so we're going to go ahead with our next kind of part of this. So we're going to bring it back over to our explanation. So when we're dealing with direct variations, we're going to see a lot of problems that kind of start with this like statement that my camera is just being a little annoying today. That the value of y varies directly with x. Okay, and so these are just going to be like, I don't know, like the types of problems you'll see, they'll tell you, that'll be like something given in the problem. So the value of y varies directly with x. So interesting, varies directly. We're talking about direct variation, so pretty much all it means is the same thing. So if you see the problems where it starts off with the value of y varies directly with x, the first thing that you're going to do is you're going to write y equals mx. Okay, so you're just going to start by writing that formula out. Okay, the next thing that you are going to do is, so usually like what's going to happen is they're going to say the value of y varies directly with x, and they're actually going to give you a couple values. So let's actually, let's like look at this example as we go along. So this is an example. It tells you the value of y varies directly with x. And whenever it says that, first thing you're going to do is just write y equals mx. Okay? And that's, again, first thing you do. What they're also going to give you is a couple of values. So they'll tell you the value of y varies directly with x. And then let's say that when y equals 6, x is going to equal 12. And so they give you that information, then they want you to find y when x equals 27. So the first step that we had here was we write y equals mx, okay? And the second step is that we're going to plug in the given y value and given x value into the y equals mx. Okay. So that's going to be our next step. So again, we'll have this problem. We have y equals mx. They're going to give us a couple values. We plug those in to y equals mx. And after that, actually, we'll just do number 3. And then what we do is we solve for our constant. And remember that our constant in this situation is just going to be our m value. Okay. So let's try that part out right now. And so actually, if you take a look over here at the example, I am going to purposely kind of do like a little line down the middle. It doesn't need to be perfect. Because we're actually going to solve this in two different ways. So we have y equals mx, and so our second step told us to plug in the given y value and the given x value to this formula. So they tell me that y equals 6 and x equals 12. So into this formula, for y I'm going to put 6, and for x I'm going to put 12. So I'm going to have 6 equals and I'm just going to put the 12 in parentheses because it's easier that way. So now my next step tells me that I want to solve for m. So I see here that m is not alone. It has a 12. So would anyone like to raise their hands and tell me what I would do next to get m alone? Oh, Sean, go ahead. Yes, I would divide both sides by 12. So if I have 6 equals whatever, m times 12, 12m, whatever. If I divide both sides by 12, 12's cancel, and I'm left with m equals 6 over 12. So if I know that I have 6 over 12, are we all okay with saying that m is going to equal 1/2? Good. So I would find that m equals 1/2. Excellent. That's great. But I'm not done yet. So they're asking me still to find y when x equals 27. So what I've done here is I've found the m, which is great. So my next step, okay, is going to be to use the constant, which I've just found. So I found the constant in this problem to be 1/2. So I'm going to use that constant to now solve for the missing value. So what that means is that I'm actually going to kind of like go back to the beginning, and remember I started with y equals mx, and what I've now done is I've actually found m. So what I'm going to do is I'm going to, and sorry if you don't have enough room, I'm going to actually rewrite the formula, but I'm going to include the m value that I just solved for. So now I have a general formula that I can use in this situation. So if I have y equals 1/2 x as my formula, they're now asking me to find y. Okay, so I want to find y when x equals 27. So does anyone have an idea of what I could do? So I have a formula. I want to find y when x equals 27. Does anyone have any ideas of what we could do? Anyone? Oh, Brandon, of course. Go ahead. Yes, you are right. I would, if I'm finding y when x equals 27, I'm going to use this formula and I'm going to plug in 27 for x. So y is going to equal 1/2 times 27. And since I know that we just can't possibly do math in our heads and must have a calculator, we're not going to use a calculator, of course. 27 divided by 2, 1/2 of 27. So we know 27 is not an even number, but 26 is. Half of 26 is 13. We need one more to get to 27 divided by 2. Da 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 da. Your answer is going to be 13.5. Okay. So what I've just done here is I've started with a formula, used some given values. I found my constant, used my constant to create a new formula, and plugged in values to find an unknown. So when x is equal to 27, y is equal to 13.5. Of course, you don't have any. Okay, so here's the thing, though. There's actually another way that you can solve this. So I know I don't have any room either, or we'll do pretty little squiggly lines, or what you can also do. So this was one kind of thing that you could do in order to solve this, but we can also do another way, and that would be proportions. Proportions. Okay. Proportions are fun. Okay, and if we're doing proportions, well, we're going to talk about proportions, but anyways, so that's what we're going to do on our second side here. So if we're doing proportions, when we're dealing with proportions, pretty much all that means is just setting two fractions equal to each other. So if I'm going to do this the proportion way, proportions. If I'm doing it the proportions way, Pretty much again, what that means is I have two fractions set equal to each other. The thing that has to be true about fractions, or about proportions though, is that pretty much like whatever is on top has to be the same that's on top on the other side. Never mind, but I'm gonna have two fractions, y over x is equal to y over x, okay? And you can do x over y equals x over y, whatever. It's gonna get you the same answer, but let's just do this for now. So for a proportion for this kind of problem, I would have some sort of y value over an x value equals a y value over an x value. So what I'm gonna do is I'm gonna use first the given values. So I have y is 6, and so I'm gonna plug that in for the y here. When y is 6, x equals 12. So again, I plug the 6 in for the y, 12 for the x. And because I know that they vary directly, this is why I'm allowed to do this. So when y is 6, x is 12. And the next part asks me to find y when x equals 27. Y remains y because that's still unknown. But x down here becomes 27. Okay? So I know that we talked about this way in the beginning of the year, which a lot of you had forgotten anyways. So the question here is, if I'm in this situation, how do I get y alone? Because remember, that's always my goal. If I have two fractions equal to each other, does anyone remember what I'm going to do? No one wants to raise their hands. Anyone? Oh, Sarah. Yes. Go ahead. What would I do? Oh, yes, you are right. I cross multiply. So when I cross multiply, I look across the fractions and I multiply those things. So 12 times y gets me 12y. I keep my equal sign. And I do 6 times 27, which just, so we're all clear, is 162. But I know that you could have done that anyways. So now I'm going to have 12y equals 162. What would I do next? Oh, Faith, yes. Yes, divide both sides by 12. Oh no, look at all this math that we have to do. Well, lucky for you, I'll just tell you that the answer is 13.5. And look at that, same answer. Same. Yay. So, again, you're going to get the same answer as you're going through, regardless of which approach you use. I don't care which approach you use, but just, I'd be conscious of, if you don't feel comfortable doing cross multiplication, I'd maybe avoid this. If you don't like that this is more steps, avoid it. I don't really care. You should get the same answer, which would then be actually a good way to check your answers because you get the same thing. So, yeah. That's about it for today. And so Mr. Perkins is going to give you your classwork at this time, and just make sure that you bring this yellow sheet with you. Make sure you follow the procedure, and you should be all set to go. So, all right, bye.